Okay, we're going to start with chapter 4. These are inverse functions, and we're going to start with the horizontal line test. And a function passes the horizontal line test if it goes through the function at most once, then the function is a one-to-one function. So for example for this one, I'm going to kind of just sketch what this would be, right? And I know that for this, my y-intercept is 0, 4, because that's my b, and then my slope is 3. So if I go 1, 2, 3, 4 is my y-intercept, and then my slope is going to be up 3 and over 1. So this line for this function goes like this. And we're trying to determine if it's a one-to-one function or not. And by that, you can draw a horizontal line through it at any point. And it doesn't matter where we draw the horizontal line, it only crosses the function at one point. That means this is a one-to-one function. Okay, that's different from this next one. If we graph this one, oops. Okay, and this is our parent function just shifted down 5. So we 1, 2, 3, 4, 5. And we know that our parent function is going to look like this. It's just shifted down. Okay, now if I draw a horizontal line through this, it's going to intersect in 2 points. Okay, so this is not, it looks like hot, but it's not one-to-one, because it crosses the function in 2 places. So here's the thing you need to remember. The vertical line test, which we've learned before, the vertical line test will tell you, it tells you if it's a function, right? The horizontal line test tells you if it's a one-to-one function. Okay, so if it passes the vertical line test, it is a function. It's a one-to-one function if it also passes the horizontal line test. Okay, next thing we're going to talk about is what an inverse is. And an inverse is a reflection over the line y equals x. And we're going to kind of look at what that looks like on the next page. Okay, if you have a one-to-one function, then the inverse is a one-to-one function when the order pairs are switched. Notice if this function has the ordered pairs of a, b, the inverse, those ordered pairs are going to be flipped. Okay, if it's a one-to-one, if the first one's a one-to-one function, then the inverse is a one-to-one function and the ordered pairs are flipped. So for this one, my y equals x line goes through here. Okay, that's the line over which it reflects y equals x. And my original line is 0, negative 2. So 0, negative 2, and 2, 0. Oops. Put it on the right. 0, negative 2. There we go. And 2, 0. So my original line's over here. And then my inverse is I'm going to flip those. So it's going to be negative 2, 0, and 0, 2. So it's going to be negative 2, 0, and 0, 2. And if you look, those are reflected across the y equals x axis. So the y equals x axis is like a mirror that reflects those two. Okay, we can do the same thing on this one. I'm going to do my y equals x line. It's supposed to reflect over that if they're inverses. All right, I'm going to, in blue, I'm going to graph all 3 of these points. So I have negative 4, 0, I have 0, 2, and I have 4, 4. Okay, so this is the original points that they gave us. Okay, my inverse points are going to flip all of those. So I'm going to have 0, negative 4, 2, 0, and 4, 4, because if you flip them, they're just the same thing. So I have 0, negative 4, 2, 0, and 4, 4. And notice, even though these cross, right, they reflect, if you look at the y equals x as a reflection point, they reflect over that x-axis. But you can find the inverse just simply by switching your x and y. Okay, so we find the inverse when we switch the x and y, and then what we'll do is we will solve for y. Okay, now remember the function of x is the same thing as y. Okay, so this is the same thing as y equals 2x plus 5. So to find the inverse, the first thing I'm going to do is switch my x and y. So this is going to be x equals 2y plus 5. Now I'm going to solve for y. So I'm going to get y by itself. So I'm going to subtract 5 from both sides. So I have x minus 5 equals 2y. I'm going to divide both sides by 2. And I have y equals x minus 5 over 2. If I split those, I get 1/2 x minus 5 halves. Because it's like x over 2 is the same as 1/2 x. And then that means my inverse function, and the way you write the inverse function is f negative 1 of x. This is the inverse function notation. You do have to write that or you're going to get points taken off. Equals 1/2 x plus 5 halves. That's the inverse of 2x plus 5. All right, so let's try the next page. Okay, we know that this is like y equals 4/5 x minus 3. So I'm going to flip the x and the y. So this is going to be x equals 4/5 y minus 3. And I'm going to solve for y. So I'm going to add 3 to both sides. I have x plus 3 equals 4/5 y. I'm going to multiply this whole thing. To get rid of that fraction, I'm going to multiply the whole thing by the reciprocal, which is 5/4. And I end up with 5/4 x plus 15/4 equals y. So that means that the inverse of x is 5/4 x plus 15/4. And I really do prefer that you leave them as fractions. And that's your result. You know, the next one's got a cube in it, but we still do the same thing. This is like y equals x cubed minus 6. So when I flip my x and my y, this is going to be x equals y cubed minus 6. I'm going to solve for y. So to get the y by itself, first I'm going to add 6 to both sides. So I have x plus 6 equals y cubed. Now to undo the y cubed, we're going to do the cube root of both sides. So this gives me the cube root of x plus 6 of all of that equals y. So that means that the inverse function is the cube root of x plus 6. Okay, now number 7 is a cube root. So again, this is y equals the cube root of x minus 1. So I'm going to flip my x and my y. So this is x equals the cube root of y minus 1. To undo the cube root, we're going to cube both sides. So I have x cubed equals y minus 1. I want to get the y by itself, so I'm going to add 1 to both sides. So x cubed plus 1 equals y. And so my inverse function of x is going to be x cubed plus 1. Okay, so we're going to add a dimension on this last page. Okay, same thing. This is y equals 6 over x minus 3. So I'm going to flip the x and the y. So this is going to be x equals 6 over y minus 3. Right? And I've got that denominator by itself. I'm going to multiply both sides by that denominator. Okay, so over here, I'm going to distribute that x, so I have xy minus 3x. Actually, I'm gonna just leave it alone for a minute. We're gonna do x times y minus 3 equals, these are gonna cancel, so that equals 6. Now, I'm trying to get x by itself, y by itself, so I'm gonna divide by x to move it back over here. That'll leave me y minus 3 equals 6 over x, and then I'm just gonna add 3 to both sides. So I have y equals 6 over x plus 3. That means my inverse function is 6 over x plus 3. Okay, this last one is the one that will trip people up, so really pay close attention to this one. First thing I'm going to do is flip my x and my y. So if this is y, that's going to become x equals y over y minus 1. Okay. First thing I'm going to do is I'm going to multiply both sides by y minus 1. So I've got x times y minus 1 equals y. And I'm eventually going to get y by itself, but first I've got to get all the y's on one side. So I'm going to go ahead and distribute this x. So I have xy minus x equals y. And I want to get the y's on one side, so I'm going to subtract xy from both sides. So I have negative x equals y minus xy. Okay, now that my y's are on one side, and I'm just going to make a little note here, I want you to get all y terms on one side. Then once I do that, I'm going to factor out the y. Right? Y times 1 gives me y times negative x gives me negative xy. So we're going to factor out the y, and that equals negative x. So I'm going to divide both sides by y. So I have negative x over y equals 1 minus x. Okay, well, I never want this to be, I want this to be in standard form. So that's going to be negative x over y equals negative x plus 1. Okay, the note I'm going to make on this one is that this is in standard form. And then the next thing I'm going to do is factor out actually before we factor anything out, let's do this. I'm going to put this over 1, and I'm going to cross multiply. So I have negative x times 1 equals y times x minus 1, negative x plus 1. And the reason I'm doing that is I'm putting the y over here, I'm getting the y in the numerator, and now I'm going to divide both sides by negative x plus 1. And that gets the y by itself. Okay, now the y is isolated, and we've got the x in standard form, but we want to factor out the leading negative. All right, so I have a negative 1 times x here, and then I have a negative 1 times x minus 1 here. And so those negative 1s are going to cancel, so my y is x over x minus 1, which means my inverse function is x over x minus 1. That took a lot of different terms. One of the things I want to point out is we wanted to get all the y terms on one side. That was one big step. I did that so that I could factor out the y. right? And then I tried to get the y, the y in the numerator instead of the denominator, so I cross multiplied. I wanted to make sure my binomial with the x in it was in standard form, and then, but I don't want the leading term to be negative, so I factored out a -1. Lots of good stuff in there. Okay, so that will conclude 4.1.